a object-oriented programming, like inheritance is very common. And the purpose of inheritance, as you know, is to increase reuse and to avoid unnecessary code redundancy. So in here, you might see that we have an employee, part-time employee and full-time employee. Of course, they have a lot of things in common. They all have an ID, they all have a name, they all have an address. So instead of repeating these common things in both classes, inheritance tells us to take the common stuff, put them in a superclass, then inherit those common things into the subclasses. And what do we put in a subclass? Yeah, the things that are specific to that subclass. So the common things get inherited, and then the specific things, we place them in the subclasses. Okay, this is very nice, very widely practiced in object-oriented modeling and programming. Now, in the database world, I'm sure you have not seen such concepts. There is no such concept as inheritance in the database world. So, but JPA is all about mapping the object-oriented world with the database world. And basically, the objects that we play with or we program with, yes, or entities, yes, the instance of entities, we push them to the database and they become records in the table. So the entities become table, and the instances, they become rows or records in the tables. So how can we map this hierarchy, this inheritance, into tables? What are the ways? Sorry? Yeah, yes, this is the mechanism, yes. The mechanism, you will add some annotations and the magic will do it for you. But you need to understand what you're doing. So forget about the annotations. Just intuitively or like in common sense, how you would go about it. How you will store. If I ask you to store, let's say you have part-time employees, you have full-time employees, and I want you to store them in a database through an entity. So you have objects of type part-time employee, and you have objects of type full-time employee, and you want to persist them or store them in a database. Sorry? No, these are not tables, by the way. These are classes. So how you will design a database to hold or to store information that is like kind of stored in objects of this type. What are the strategies? How we can store instances of these classes in a table? Yes, please. No, it's good. Okay. Okay, excellent. Yes, this is very good. Very good, yes. So one strategy, which obvious one, is that we create one table that has all the columns. We create one table, we take these attributes, add them to the table. We take these specific attributes, add them to the table, and take these specific attributes and add them to the table. One table that has all the attributes. Of course, we need one extra attribute to distinguish between the two, like let's say employee type. Okay, very good. So this is excellent. So one strategy is to create a single table that has all the columns, the common columns and the specific ones, with, of course, one extra column to distinguish between the two, between a full-time and part-time. Okay? This is good. What is the advantage of doing this? Putting them all in one table. What's the advantage? Yes. So yes, very good. What is the advantage of using one table? Query for one table. Very good. So when you want to get employee information, you just query one table. Very good. You don't need to do any joins or anything. When you insert into one table. When you update one table. When you delete one table, okay? But what is the disadvantage or the price? Yes. Yeah, you might be big. If you have a big hierarchy, the table might be very wide with a lot of columns. And plus, as you mentioned, the columns that are not relevant will be null. You have a lot of null columns. For example, for full-time employee, they don't have an hourly rate, and they don't have a number of hours they work. So these two columns will be null. And for part-time employee, the poor ones, they don't have a salary, and they don't have an office. So these two columns will be null for part-time employee. This is fine. For a small hierarchy like this one, it's fine. Couple of null columns, it's not a big problem. But if you have a complex hierarchy, either it is wide or deep. Because remember, the hierarchy can go deep, a lot of subclasses. Or it can come wide. You might have foreign employee and so on. Yeah, local employee, a lot of other intern, could be other type of employees. Seasonal employee, volunteer employee, so many others. Okay, so the other price you pay is that if you have more subclasses, what will happen? Yes, you will have to change that single table and add more stuff to it. And that table any change you do in here will affect that table, of course. And that table might be used by other queries or by other reports, and you might break them. So that table gets changed every time you change anything in the hierarchy. So you need to be aware of this if you go with the single table strategy. What's another strategy? What's an alternative one? Yes, you do it as it is here. This will come one table. This is one table. This is one table. Yes, very good. So the subclasses, we will add a foreign key, which is the ID of the superclass, to join them. And you will have one-to-one relationship. So in this case, you will have how many tables? 3. Okay? So what is the advantage of this strategy? Okay, a much better way of saying it. Smaller table. It's more normalized table. So the normalization people will have a big smile. They're happy. You are following all the normalization rules. Okay, and when you look at your ER diagrams and class diagram, very, very similar. Have a look at this. When you have a single table, your class diagram is very, very different. You have 3 diagram, and your ER diagram, very different. Have a look at this. This is the joint one. You have very similar diagram. Okay, but the most important is the most important advantage is that you have a normalized database design. What is the price? Nothing is for free in this world. Thank you. Less efficient. Because whenever you need to read, you have to join the common with the specific to get the result. Okay? When you want to insert, a new employee came in, 2 tables. In this case, yeah, 2 tables. The common stuff, it goes into the employee table, and the specific ones will go into the specialized, yes, the specific table. Okay? But if you have more subclasses, what will happen? Very good. You create another table. So in terms of maintenance, is this better or worse? Better. Of course, better. Because adding things is less likely to break other things. Because adding the old stuff, they are not aware of the new tables, so there's no chance of breaking them. But changing existing things have the likelihood of upsetting existing queries or existing tables. You get the idea. So in terms of maintenance, is much better. Okay? So you see here, there's advantages and disadvantages of each approach. So what is the third way we can do this? Table per concrete class. What this means? Which class? subclass. Very good. So how many tables we will have here? 2. What is the schema of each table? The, yes. Very good. We take the common one, we push them down, and we create one table. We take the common class, push them and merge them with the specific ones, and create another table. You took this JPA? Okay. Okay, good. So you had some inheritance hierarchy and you were asked to map them to tables. Is that correct? Not really. Okay. Oh, without classes. Okay. Okay. So basically, it's good. I think you did very good in here. So this hopefully will make a lot of sense. So there are 3 major strategies. Single table. This is the default. In terms of JPA annotations, if you don't do anything, it will be a single table. Joint strategy or table per concrete class. Now these are the annotations, the concrete annotations you need to put on top of your entities. So for the single table, you just add this annotation inheritance. Strategy type is a single table. And you add one more annotation called the discriminator column. The column to be used to distinguish between full-time and part-time. In this case, the discriminator column will be employee type. You can see here, there's a new column added here, employee type. Now, in the subclasses, what you put is the discriminator value. You see here, the discriminator value. This is very, very well designed, this JPA. So very nice annotations, very meaningful. On the superclass, you put the strategy is single table. And the discriminator column, you say what is the name of the discriminator column, what is the type, in this case char, because one character. And then on the subclasses, you put the discriminator values. Now, when you read, let's say you say entity manager dot find, and you put in employee.class, comma, the employee ID, you will get one of the subclasses. If the employee happens to be full-time, you get a full-time employee instance. If it happens to be part-time, you get a part-time instance. Okay, you get the idea. So the system will work out which one to give you based on the discriminator value. Okay, so that's basically the annotation, and these are the advantages and disadvantages that we discussed together. All right, the joint strategy, this is how it looks. We already discussed it. And this is the actual annotation. You just come and say, OK, the inheritance hierarchy is joint. That's the only difference. The rest is the same. And by changing from single table to joint, you will end up with 3 tables instead of 1. But you still need to have the discriminator column, and you still need to have the discriminator values. Okay, the exact same annotation, except the strategy, you change it from single table to joint. And these are the advantages and disadvantages. You need to be familiar with this because these are the type of questions you might get in the theory. Okay, per concrete class, super simple annotation. You just say table per class, and that's it. This one is extra. It's not really necessary. This is an image. This is just changing the table name. Okay, and the reason why people change the table names, I put here underscore. Can you see here? Underscore. Yes, very good. Thank you very much. Some databases, they take it on themselves and they make all the table names and column names uppercase. Okay, including I think Oracle and including JavaDB. But if you take something like SQL Server, it does not do so. It respects your column names. Okay, but that's why when you have a table made up of 2 names, you separate them with the underscore to keep your administrator happy and to keep everyone happy. Okay, but if you are using something like SQL Server, it will keep it. If you put it full-time employee, you open your database, you will see full-time employee. If you use something like Java, DB, or Oracle, you ask it for full-time employee, you make it full-time employee uppercase, which is much harder to read. That's why we added this underscore. Although this is not very good, we could just come here and say name and put the name of the table. Okay. Anyway, bugs. Not bugs, but it's not very, yeah, this is added stuff that are not necessary. In coding, very important. You go with the minimum that works. This is the strategy. Don't add. Like, don't try to be more sophisticated. You go with the simplest thing that works. That is the basic idea. All right. So I already explained this. Now, I think we didn't talk about this in terms of the advantages and disadvantages. What are the advantages of this approach? If you go with a table per class, what's the advantage?
It's better in maintenance if you want to add one more.
Yeah, kind of medium, yeah, because yeah, it's yes. Yeah, it is better. It is better than the single table, definitely. Yeah. Yes, if you add more subclasses, you just create a new table. Yes. So maintenance is better, yes. In terms of normalization, is it normalized?
No, because we add an extra attribute.
No, it is normalized. It is normalized. There are all the columns depend on the primary key. Sorry?
Maybe not high level. Not like the...
No, in terms of normalization, it is normalized. It's very good because no, but there is functional dependency between all the columns. Okay, because the concept of redundancy in database is different. Because basically you don't want the data to be repeated in multiple places. Okay, but in here the data is not repeated. Here it could be. We will not find here. Let's say Fatima in here and in here, same person twice in multiple places, or you will not get that problem. You don't get columns that are nullable unnecessarily. So in terms of normalization, it is fine. Now, what is in terms of queries? Is this good or not good?
Yeah, it is, because you just need to join.
Yeah, basically, if you are inserting, you insert into one table, updating one table, reading from one table, except there's one thing, no, even deleting one table. So for querying, for specific queries, it's problematic. Think about it. Get all, thank you. That's it. If you want to know, let's say I want to know what are the employees with age less than like 30 years old and younger than 30. Yes, basically what you do in a querying, not join, because join is different. You select from the first table, you select from the second table, and what do you do? What's the operation you do to bring the two results as one result? A union. Okay. So you do a union, which is a very costly operation. It's even worse than join. Okay. So the only case where this is not efficient, if you have a lot of queries on the superclass. If you're doing a lot of queries that target the superclass, you have a problem, because you have to do it in the two tables and then union the results. But if most of your queries are on the subclasses, you are fine. Okay? So that is basically the idea. So these are the strategies and these are the annotations. You select the one that's best suit the scenario that you are working with. So this single class is good when you have a small hierarchy. It's very good, like the one that we have, very simple hierarchy. The joint strategy is good when you have either a large hierarchy or a deep hierarchy, because basically you're creating a table for each. You're creating a table for each specific subclass. And this one is good when you have basically a wide hierarchy, then not deep. If you have a deep hierarchy, you will end up with so many tables. All right, so what else? Do we still have a bit of time? Yes, we have a bit of time. There is one more topic two things I want to quickly. Here, I think I kind of started discussing this, but I just want to give another few minutes. So the JPA, Java Persistence API, it's an example of this technology called Object Relational Mapping that tries to bridge the gap between the two worlds. So it's just an example. In MongoDB, for example, the Mongoose that you did in assignment 3 and project, you can consider it as another type of object relational mapping. Not relational in this case, object document mapping. Because you describe the schema, if you remember, you describe the schema, and then you deal with the schema to save or retrieve or query, and the Mongoose will generate the actual queries on your behalf. So it is considered as some kind of object document mapping in this scenario. So this idea is not specific to JPA. It is a generic idea. So it is to bridge the concepts. As I explained before, in object-oriented concepts, you have classes with attributes and methods. You have composition. You have inheritance. In the database world, you have tables, columns, primary keys, foreign keys. Different world, different concepts. But really, there is you can bridge them. You can map those concepts. And basically, before this technology, developers has to do the bridging by themselves, by doing writing a lot of SQL and doing lots of transformations manually themselves using code. And this ORM basically comes to bridge this gap between the two and makes it super easy to take objects from your objects, take data from your objects to the database, and vice versa. Much, much easier. So basically, once you add the annotations, once you add the annotations to your classes, you get a lot of benefits. I explained before, you can generate the database from that. You don't need to write a lot of queries. You just ask the entity manager, let's say find, as an example, find, and you give it the ID of the record you want to find. It goes and gets it for you. In the background, it will generate select star from table where ID is equal the ID parameter. So the other thing, of course, you can map associations, you can map inheritance, you can map all the features you have on object-oriented programming to the corresponding mechanisms or implementations in the database. Okay. Then, once you have those annotations, you use a very nice API, primarily this entity manager class, and you use it to either push an object to the database or you use a query to query the database through this entity manager. All right. Now, to summarize, like JPA, if you want to learn it, that's what we did. You learned three major things. The mappings, the annotations that you need to place on your entities and sometimes on the attributes of your class. The other thing is the entity manager API, the methods of the entity manager. And this one, persistence.xml, it's a kind of, you need to be aware of it because that file is very critical. It has the configuration information. Yes, to connect, to tell JPA what are the connection parameters to get to your database. All right? And this is how it looks. Also, in our case, you can have these GlassFish resources to configure your pool and your data source. So you don't need to create it using the visual interface in the GlassFish administrator. Now, the other thing I want to show you, which have another 5 minutes, is just to remind you of the JPA programming. We already kind of seen it. I just want to quickly go through it again. So the entity manager is the most important class. It has this lifecycle API. Lifecycle means the methods to read, write, find, delete, update. This is the lifecycle of the API of the entity. And you also have, from the entity manager, you can create queries. And there are three types of queries. One is called named query, and a query, and a native query. So named query is a query that you give it a name. Let me show you. Maybe we haven't seen. Yeah, we haven't seen this. Yes, yes. Yeah, that is fine. Let me just show you very quickly. So if you go here, just be familiar with this. So let's say customer. So I come on top of this entity and add this annotation. Basically, this is a query. So let me take something, oh, both of them are complex. Let me just take something simple. Okay, this one, simple. So here is a query. So I come to this class and add this annotation named queries. Named query is a query that has a name. And here is my query. Select from order where the customer is equal to a parameter called customer ID. So I take this and give it a name. And then when I want to execute it, I go entity manager dot create named query and give it this name. This name. Okay, and set the parameter. Okay. So what is the advantage of putting a named query? Okay. So I have to put it somewhere, isn't it? So the okay, very good. Yes, good question. So basically, that's how they designed it. How the JPA people designed it. Yeah, it must be as an annotation on top. Because the repository does not have any annotations specific to JPA, except the annotation for the entity manager to get an instance of the entity manager. So, and this, you put it in any of the entities. It does not necessarily mean one particular one. It should be on top of one of the entities. But what is the advantage of doing it this way? There is a big advantage. Sorry? Reduce complexity of query. Yeah, kind of, but you still write it anyway, because this, you can reuse it. You can reuse it easily, so you don't need to write it again and again in multiple places. You write it once. But more importantly, this query will be compiled at a runtime. When you run your application, when you compile your application, if there is a bug, for example, in here, you put this one S, or maybe this one lowercase, it will not compile. You remember in SQL, it's a string. When you do an SQL statement, it is a string. If it has an error, you will not find that error until you run the application. Okay? When you say run the application, if you are not careful, you will ship it to your users and embarrass yourselves with your users. Okay? You don't have the chance to pick it up at compile time, except if you do a lot of careful testing. But in here, it will not let you go if you have an error in your query. Because these queries are against the object or the class. So the class, because the system knows the structure of the class, so it will not let you do silly mistakes in your query. But if it is a SQL query, an SQL query, you are on your own. If you have a mistake on your query, the compiler will not be able to help you, because for the compiler, that is basically a string, has no meaning. That meaning will come at runtime. Are you following? So this is the major advantage of having a named query, is that they get compiled at the compile time, and if there is a mistake, it gets reported by the compiler to you to fix before you ship. So this is how you create the named query. This name is global. So all the queries, the name should be unique in the whole application. That's why it's a good idea to always name it the entity on which it is present dot the name of the queries. This way you can make it less chances of having conflicting names because the name is unique. All right, so
So then the class or entity becomes serializable in this case?
no, it has nothing. No, this concept has nothing to do with the serializability.
So why we
Sorry, this one. This you mean here?
normally
Here, no need. This is no need.
yeah. Okay, so
Yeah.
it's the same meaning in
Yes. You don't need this one because these days we are serializing using JSON and XML, not binary serialization. So that annotation has no value in the latest version because binary serialization is not platform independent. It cannot help you on the web. The web is not Java based. The web is text based. So you serialize to XML or JSON. So no need for that implement serializable. Okay. Sorry, you had a question? And then I'll let you go.
لما كنا نعمل بداية ما بيطلع لنا 20 يعني ما بيطلعوا 90 واحد
Okay. You sure?
يعني من الجسم فيه التسريع مثلا والتابل فعليا جواه بس 20 ما نقدرش اكثر يعني
No, it should be a bug in your implementation. How come? You have 90 and you only insert 20 get insert?
لما لانه هو فعليا الشوينج بتصير بس بنشوف 20 بس فعليا لما سويت اد وقراته من نفس الداتا بيس وقرأ 90 كلها بس فعليا الشوينج مش مرق اصلا 20 يعني رصيد بس من 20
When you query, basically, when you query?
لما اسوي سيلكت ستار بيجي مع الاد مع العادل
Okay.
بس فعليا الشوينج انه نسوي فيو تيبل ما بيجي الا 20
At the view table, maybe there is a next. You mean in the yeah? You mean in that tool in the services? Yeah, maybe there is a button there to go next and show the other ones. Yeah, definitely. But that is just a tool to visualize the data, to visualize. Yeah. Sorry, I will just stop this one.